In this video, we're going to learn how to translate a triangle. We've already learnt how to make a set of parallel lines. For instance, if I want a line parallel to this one, I can just move that one up there. If I want a set of parallel lines to this one, move it up there, and so on. So let's just do that and see what happens. We're certainly going to get something, and we should find that with a little bit of care we can get a triangle. So that's parallel to this. Now, in order to distinguish these two from the other lines, we put a little arrow on there to say they're parallel. Now, I would like to move that one up. So before I put my pencil point there, now I can see I've got a degree of adjustment there, tiny bit of adjustment. That's correct. Now I can move that one up to there. And this time I'm going to put on two of these marks to indicate that those are parallel lines. And finally I want to move this one up. So how am I going to do that? I want it to go up to there. So maybe if I put that in this position, I'll be able to do that. Once again, put my point there and move it around. So that's a nice straight line. Up we go. And I've got a third straight line, pair of straight lines which are parallel. So there we go. Now these two triangles are clearly members of the same family, because we can see straight away that that angle and that angle are the same. This angle and this angle are the same. Those two. And finally this slightly obtuse angle is the same as that one. But the one is not a translation of the other, because the lengths are not the same. The lengths are different in each case. And so these triangles are said to be similar. Now, similar triangles are not obtained by translations. What you get if you translate are congruent triangles, which means that not only the angles are the same, but the lengths are the same too. Well, we've done one of these, and I think you can pretty easily see how we could put another similar triangle here or here by rearranging our set square and ruler. But what we're really after is a translation, which means that we have to work with congruent triangles. Well, let's draw another triangle here. Keep it nice and simple, not too big for the paper. And now we're going to translate it. So the first thing to do is to say move that line over in this direction. Let's see, make sure that's nice and straight. Just adjust it a fraction. There we go. I'm going to put it over here. But I want to measure it to make sure that this length and that length on the parallel line are the same. So I measure that one carefully and I get 4.9. So I can choose a point there and mark myself 4.9. It's going to be there. So now I know that this line and this line, which are parallel, are the same length. Now I want to move that one over to there. How am I going to do that? How can I put the ruler in the right position? Well, let's see. That's nice and straight. I'm going to move that one over to there and draw my line in. Now, the last thing I need to do is to put this line, as it were, up here. So I want to slide that one up. Now this is the beginning of that line, so if my new parallel goes through there, that's it, then I would have done all I need to do. There's my third line, and because I've got one measurement correct, all the other ones must be correct as well. Now let's dress it up a little bit. That line is parallel to that one, and this line is parallel to this one here. Let's call this triangle A, B, C. We can call that one A dash, C dash, and B dash. And we can now write that triangle A dash, B dash, C dash is congruent to triangle ABC, and we can also say triangle A dash, B dash, C dash is a translation of triangle ABC. And it's so many steps in that direction, isn't it? I don't know, in this direction, for instance, it's been moved perpendicularly to about 6.5 centimeters in that direction. When we move on and study these topics of translation, reflection, rotation and enlargement in the textbook, you'll see it's usually done with a grid. And now there's our centimeter square. I'm going to turn it into a Cartesian grid. Notice if I want to write with ink or draw with ink on top of pencil, then if I turn this over, you can see there, this is actually what's called a trapezium, and the reason for it is that when I draw with ink, if I turn the ruler upside down and draw with ink, then it doesn't smudge. That's the reason for this particular shape, and it looks nice. So there's our grid with which you should be familiar, and we measure that 1, 2, 3, 1, 2, 3, etc. Now if I want to translate a shape, then I need a shape to start with, so I would normally be working with something like a triangle. Let's say I've got a triangle here, and if I'm going to translate it, I need to know how many steps to move it right or left or up and down. So I'm going to move it, translate it, 3 steps to the right and 1 step up. So that point will go 3 steps to the right, 1, 2, 3. That point will go 3 steps to the right and 1 up to there. Sorry, that goes 3 to the right and 1 up to there. That's, in order not to get to a muddle, let's call that B, and call that B dash, and call that C, and it's going 3 steps to the right and 1 step up, so that's C dash. And this point here, we'll call it A, it's going 3 to the right and 1 up. So that's how you can do it on a grid if you can't follow the very simple procedure of using a set square to translate a shape without a grid. And of course the grid has got its own advantages in terms of making it easier to measure. As a grid is really, you've got one ruler running up that way, and you've got one ruler running from left to right, and therefore it's possible to measure as accurately as you please the position of any point on the grid.